The new section is entitled Logical Statements. Have to first deal with a few definitions. Need to be a little bit open-minded to realize that P and Q are statements. I just made that fact, that I just stated that P and Q are always statements, always, for all logic problems, not just for this one particular problem. P might be, if it rains. Q might be, I'll go roller skating. And we talk about statements like, if P, then Q. If it rains, then I'll go roller skating. That would be what if P, then Q meant if P was, if it rains, and Q meant, I'll go roller skating. Now, what's the negation? For example, what is the negation of P? The negation of P is denoted as not P. The curly symbol in front of P means not. So that, of course, means not P. It's not P. It will not rain. If P means it will rain, then, of course, not P means it will not rain. So we just defined not. Let us define another term. Let us define, or we define, negation. Let us now define converse. The converse of if P, then Q is if Q, then P. Basically, you switch these. If Q, then P. And that's the converse. Now, our converse is always true. If you study, then you'll pass. Then you will pass geometry. Now, so if I interchange these two, how do I identify those two? Then the first part is in between if and then, and what comes after then is the next part. The two parts, the P and the Q, are what I put boxes around. If you study, then you will definitely pass. Now, must it be true that if you pass, then you studied? That would be the converse. The answer is no. You can pass by not studying. Maybe you cheated and you passed. Maybe you're just really bright and you don't need to study and you pass. But guarantee you, if you study, then you'll pass. This was the given statement, and the converse does not have to follow. If you interchange the P and the Q, it doesn't have to follow. That's exactly what a converse is. And converses are not always true. They might be true, but they don't have to be true. Okay, the next word we're going to talk about is inverse. They're inverse of if P, then Q. This is going to be if not P, then not Q. You negate both of them. Is if not P, then not Q. If you study, then you get an A, or you pass. If you study, you will pass. If you study, then you will pass. Is the inverse going to be true? If you negate both of these and keep them in the same exact order, by saying if you don't study, then you will not pass. Then you will not pass. That's not always true. We talked about some bright people or some cheaters who don't study, but yet they pass. Maybe you have a teacher who passes everyone. So whether you study or not, you'll pass. Let's suppose you have a teacher who passes everyone. Your teacher still can say, if you study, you'll pass. And that's true. His teacher failed to say, if you don't study, you'll pass as well. Okay. So what we learned here is inverses are not always true. If you know if P then Q, you can conclude if not P then not Q. That's not guaranteed to be true. Okay, the inverse of if P then Q is if P then not Q. Now we have the contrapositive. The contrapositive. The contrapositive of if P then Q is we switch the two and we negate them. If not, remember that symbol means not. If not Q, then not P. Now, is this statement always going to be true? And like always, we have to think about it. So let me write it down cleanly. If not Q, then not P. Well, we know this statement was given. That is, this statement is true. If P is true, then I guarantee you that Q is true. Well, if P is true, then Q must be true. So if Q is not true, if we don't have Q, if we have not Q, well then P can't be true. Because if P is true, it must follow then Q is true. So this statement is actually correct. If Q is not true, there are two options temporarily. If not Q, then we either have P or we don't have P. Well, let's suppose we have P. Well, that can't be, because you were told if P, then Q. That is, every time you have P, you have Q. Every time you have P, then you have Q. Well, if you don't have Q, you can't have P, because we were told. This is what we are told. We are told this. Every time you have P, you have Q. So if you have P, if you don't have Q, but then you have P, there's a problem. Because if you have P, then you have Q. But that contradicts what I'm saying. I'm saying you don't have P. So the bottom line is, if you don't have Q, you can't have P. So then you must have not P. They're both the same statements, they're just written differently. Suppose I tell you, if you study, then you pass. Then you pass. What if I say now, you didn't study? You didn't pass. If you didn't pass, why is that? It's because then you did not study. You did not study. It couldn't be because you studied. Because if you studied, you would have passed. Okay. The bottom line is contrapositives are the same statement. The contrapositive of if P then Q is if not Q then not P. And those are the same statements. It's just another way of saying the exact same thing. It's another way of saying the exact same thing. Now, just a little notation. If P, then Q, you can also write this as P implies Q. If P, then Q. Okay. So now, again, want this in front of us. Let me put it here. The converse of P implies Q is Q implies P. Switch the two. Just switch them. Don't do anything more. Certainly don't do anything less. The inverse of P implies Q is you negate the P and the Q, but you don't switch the order. P guarantees or implies not Q. And the contrapositive of P implies Q, you switch the two, that is Q and P, but you also negate them. Not Q guarantees not P. If P, then Q means P guarantees Q. If you have P, then you have Q. One guarantees the other. Okay, so let's talk about arriving at some conclusions. How about I tell you, if apples grow grapes, and nobody says these statements have to be true. If apples grow grapes, that's one statement. Sorry. If apple grows grapes, then elves eat earthworms. Okay, if apples grow grapes, then elves, believe it or not, eat earthworms. Another statement. If trolls don't tell tales, then wizards weaves willows. Then wizards weaves willows. And last statement, if trolls do tell tales, then elves don't eat earthworms. If trolls do tell tales, then L's don't eat earthworms. What can we conclude from these three statements? Draw a conclusion from these three statements. Well, the first thing, I want to see one thing. Okay, good. First thing is, maybe we'll call this A, and we will call that statement B. So we have if A, then B. That is, A implies B. Okay. Now, let's just go down to this one, the third one, only because they talk about trolls do tell tales, and here they say they don't tell tales. So if I were to call this statement C, trolls do not tell statements, and then L's don't eat earthworms. Well, we know what this statement is called. I've already named it. I named it B. I named it B. That is, I really should say it's not B. L's do eat earthworms is B. Remember, the first statement was A implies B. Okay, so L's not eating earthworms is not B. So C implies, C is if trolls do tell tales, then not B. L's do not eat earthworms. Okay, now let's go back to the middle statement. If trolls do not tell tales, this statement here. Well, I know that I call C trolls do tell tales. So not C, if trolls do not tell tales, it'll be not C. Then, if trolls do not tell tales, then that means implies wizards eats willows. And I'll call that last statement D. And the question is, what can follow from this? Now, basically, you want to get a chain of events. First, let me make this statement. If X implies Y, that is, every time X is true, then Y follows. If I also tell you that Y implies Z, every time Y is true, then Z is true. Well, then we can conclude that every time X is true, Z is true. Because X guarantees Y, and Y in turn guarantees Z. Every time X is true, Y is true. That's what this says. But also, every time Y is true, Z is true. So if X is true, we happen to know Y is true, which guarantees that Z is true. So every time X is true, we can say that Z is true. Have the transitive property. Notice that in this statement, the implication ends with Y, and in the next statement, the implication starts with Y. We want to get that link. We want to get that link. So when I look at these three statements, I notice that the first statement, it ends in B. Now the second statement ends in not B. Now you can only use either this, you can only use these three, or things equivalent to those three. Well, if only it said B first. If only this second one said B first. But the contrapositive gives us that. I can switch these two so long as I negate it. If you negate not B, you have B. And if you negate C, well, then you get not C. So basically, I'm not going to use the one they gave us, that C implies not B. I'm going to use the contrapositive. Now we have A guarantees us B, which in turn guarantees us not C, which in turn guarantees us D. So the conclusion is every time you have A, you're guaranteed to have B. Because every time A is true, B is true. And every time B is true, the next statement, don't worry about the name of the statement. I don't care that it has a not in front. Every time B is true, the symbol not C is true. And every time the symbol not C is true, D is true. So we conclude that A implies D. Now what was A? Looking at the very top, it says that if apples, because this is if A then D. If, and A is apples grow grapes. If apples grow grapes, then D. And D is wizards weaves willows. Wizards weave willows. And there's the answer. What can we conclude? If apples grow grapes, then wizards weaves willows. Let me show you how you can make up these things. Suppose you say if, and whatever I put in here I'm going to call A, if you study, then you get an A. Okay, that's going to be B. If you get an A, if you get an A, then you get on the honor roll. Then you get on the honor roll. And these two statements I'll call C and D. Next statement. If you get, and notice how whatever the conclusion is, then you study, I start off with that next. Then you get on the honor row, I'm going to start with that next. Then you get on, if you get on the honor roll, then your parents get you a new car. Then you get a new car. This is E and statement F. Oh, actually, that's not exactly true. I mean, it could be, but it doesn't need to be. I've already said that B is you get an A, and you get an A, so that's B. Excuse me. So this is B. And just to keep up with the order of the alphabet, how about we call the next one C? You get on the honor row, that's C. So getting on the honor row is still C, and getting a new car, we'll call that D. Now, I just want to play games with some of them. I can only take the contrapositive if I want to change it. Otherwise, it won't be equivalent. So, here's what, say, the author would have in their head, and then they'll write the problem as follows. Now, you can put these in any order you want, whether you use contrapositive or not. First, I'm going to put the second statement. So here is a problem that you can see in our textbook or on an exam. If you get an A, then you get on the honor roll. And then you pick a second statement. I already used up statement 2. And again, any statement you can use the contrapositive. That is, you switch these two and you negate them. And let me put one next, and I'm going to use contrapositive. If you get an A, well, we want to negate that. If you don't get an A, then you didn't study. Then you didn't study. So we just use a statement 1. Now statement 3 remains. So I write down statement 3 next. And I won't use contrapositive. If you get on the honor roll, then you get a new car. Okay. Now, I forgot to do one major thing with the top 3. What is the conclusion of the first 3? It says, if you study, then you get an A. But if you get an A, which you will get if you study, you will get an A if you study. If you study, then you get an A. And if you study, then you get on the honor roll. So if you study, you get on the honor roll. But in turn, if you get on the honor roll, other things happen. Get a new car. So if you study, you get a new car. That's the conclusion from the original 3 statements. But the bottom 3 statements, these down here, they're the same as the first 3. Either they're downright exactly the same, or it's a contrapositive. The order doesn't matter. I wrote it down the way I did on the top, so somebody who's writing up a textbook could foresee the future. This is what they wanted to see happen. If you study, then you get an A. If you get an A, you get an honor roll. If you in turn get an honor roll, you get a new car. And then you play games with it. They put it out of order, and they might use contrapositives. So what I would do is I would look at things that don't have negation. If you get an A, I'll call that A. Then you do get on the honor roll. That's not a negation. I'll call that B. The next statement, it says if you don't get an A. Well, I know what that is. That's not A, because A was, you do get an A. Oh, no. Yeah. Okay. Now, study. If you get an A, okay. So, we don't have anything that says you do study. So let's just call that the next letter in order, C. Now, the next one is you get on the honor roll. But we've already said that was letter B. And you're getting a car we haven't mentioned yet. So the next letter in order is a D. Okay. So let's look at what the first statement says. If you get an A, which is represented by A, then you get on the honor roll, which we're calling B. A implies B. Let's go to statement number 2. Not A implies C. Just for the record, if C means you don't study, then not C, the negation of that. If it's not true that you don't study, then not C would mean you do study. Okay, the last statement. If you get on the honor roll, which is B, then D. Then you get the new car. Okay. Now, I can see that, let me number these. I can see that if you use A first, A implies B, and then you use 3 next, which says B implies D, then you know A implies D. If you get an A, then you get a new car. The only concern, okay. Okay. But there's a stronger thing we can say. Notice we didn't involve C in this problem. If you negate this one, contrapositive, you switch the A, not A, and the C, and you negate them. You negate the C, and you get not C, and you negate not A, and you get A. And then we use the top one. This says that A implies B. And this one, in turn, says that B implies D. So if you don't have A, I meant to say if you don't have C, we guarantee A is true, which guarantees B is true, which guarantees D is true. So not C guarantees D. But not C is you do study. We've already said that. This means if you study, because that's not C, then D will happen. And D is you get the new car. Then you get a brand new car. But we actually had that just by using A and D. Actually, we get a different statement. If you study, then you get a new car. Okay, you want to try to use all the letters. If you study, then you get a new car. This is exactly how somebody like an author makes up these problems. They make it up straightforward first. If A, then B, and then B, then C, and then C, then D. So A implies B. And then they jiggle those 3 statements around, and they can use contrapositive on some, none, or all of those 3 statements. And of course, there can even be 4 statements. All right, let's see another problem. How about we write things in if-then forms? Suppose 21-year-olds are allowed to drink alcohol, are allowed to drink. So, if what, then what? The answer is if. So the question was to write this, let me state it again, to write this in if-then format. If you are 21 years old, then you can drink. Of course, it also means if you're older than 21. If you are 21 years old, then you may drink. Here. Opposite sides of a rectangle are congruent. Now, none of these statements have to be true. That's not what it's about. Opposite sides of a rectangle are congruent. If what, then what? if you are two opposite sides of a rectangle, then you are congruent. Let me not say are. How can you be both? If you have two opposite sides of a rectangle, then these two sides are congruent. And of course, since we're writing in English, you can word it differently, but it better be if, and then you better talk about the two sides, two opposite sides of a rectangle, then you better somehow say those two sides are congruent. Suppose you say, I live in Brooklyn, New York. Brooklyn, New York. New York is a state, and Brooklyn is the city in that state. So, if you live in Brooklyn, then you must live in New York State. If you live in Brooklyn, a city in New York State, if you live in Brooklyn, actually it's part of a city in New York State, but let's not get into that. If you live in Brooklyn, then you live in New York or New York State. Everyone who lives in Chicago also lives in America. So, if something, then something. Well, it basically says if you live here, you also live there. So if you think about it, the first part is here, Chicago, and it's in America. America is the bigger one. Even if I reversed America and Chicago, doesn't matter. Nobody says the statement has to be true. Chicago, in Chicago, you're in America. So if you're in Chicago, if you live in Chicago, then you live in United States of America. But again, it doesn't have to be true. I can say, if you live in America, you must also be living in Chicago. Doesn't matter if the statement is true. It's saying that everyone who lives here also lives there. That is, if you live here, and I don't care what it says, Chicago, America, North Carolina, Cuba, doesn't matter. If you live here, you also live there. So you would switch it. And like on an exam, there's absolutely no need to say this is the full statement. It's not about that. It's not about that. It's not about that it's reversed. How can I make it not reversed even? I can put another city down here. Okay, just put another city. Okay, you put San Francisco. Of course, if you live in San Francisco, you don't also live in Chicago. But that's not what it's about. Okay, that's not what it's about. Don't analyze the statement as being true or false or absurd, or you're not sure because you're not up on that material. No. Doesn't matter. Whatever they give you, you assume to be true. You assume that if you live in San Francisco, then you live in Chicago. Okay? Now, how would you say that as an if-then statement? And it will be, well, since everyone who lives in San Francisco also lives in Chicago, then you'll say if you live in San Francisco, then you live in Chicago. Doesn't matter if it's true or not. If I say 7 plus 2 equals 19. If you add 7 and 2, then you get 19. Then you get 19. Just like if I put the right answer, 9. If you add 7 and 2, you get 9. But I'm saying 7 and 2, you get 19. I could have written it in words. And same question, write it in if-then format. When you add 7 and 2, you get 19. When you add 7 and 2, you get 19. If-then, if you add 7 and 2, then you get 19. That's how you write things in if-then format. Okay. Suppose I give you, because I think these are important, suppose I give you some implications and I ask you to come up with a conclusion. Suppose I tell you that A implies B and B implies not C, and not C implies A, and B implies F. So what you want to try to do is get them linked. For example, A implies B, but B in turn implies F. So I know that A implies F. Now, this one ends with C, A. It ends with A. So not C implies A. So let me just do something. Right here I use B implies F. Over here I use A implies B. I just use not C implies A. Well, this one says every time you have D, you have A. I meant not C. Every time you have D, you don't have C. So D guarantees not C, which in turn guarantees A, which in turn guarantees B, which in turn guarantees F. So D guarantees F. And that is my conclusion. That is my conclusion. These 4 statements tell me that D guarantees F. Let's try another one. Suppose that P guarantees not Q, and R implies Q, and S implies R. Well, I noticed that the last two link up nicely. S guarantees R, that's the last statement, and the one before says R guarantees Q. But this statement, I can't put it in front because it doesn't have an S there. If it would have said P implies S, then I would say P implies S. But it didn't say that. Nor does it start with Q implies something. If it said Q implies whatever, whether it be not Q or whatever, I'd be done. I would say S implies not Q. But it doesn't say that, so let's get rid of it. So I would then think contrapositive. I would switch the P and the not Q. The P is first, it goes last, but I negate it. The not Q comes first, so let me write not Q. It's a typo. It comes first, but I negate it. If you negate not Q, it just becomes Q. The first statement is logically equivalent, meaning it's the same as Q implies not P. Oh, Q implies not P. Okay, Q implies not P. Now I have my linkage nicely. Everything links up, and I now know that S implies not P. And if they told you what P, Q, R, and S were, wonderful. So then you would say it in words. But just call the statements P, Q, R, and S. Let's try another one. Suppose I tell you A implies B, and C implies D, and not B implies not C, and not A implies E. I think this will work out nicely. Now, when I look at this, let's look at the first one. Let's number them. It ends with B. None of the others start with B. Okay? Not a big deal. This one starts with A. Like A implies B. You would want another statement. You would want another statement to end with A, like X implies A. But not 2, 3, nor 4 start or ends with A. No, no, no. So now you're like, oh my. So now you have to start thinking contrapositive. You remember you wanted it to end with an A? Well, if you look at number 4, I can get it to end in an A. I can switch these two. So let me write down A implies B. If I switch these two, it will become not, and negate them. Switch and negate. E becomes not E, implies not A becomes A. Oh, okay. So not E implies A. So I used 4 and I used 1. Okay. And I guess I have a little typo here. Sorry. The B and the C, I think I meant to switch. B and C. So nothing of the remaining two, none of them mention anything about E. But some of them mention about B. And I would like B first. I want to know what B implies. But I have a B, but it's second in statement 3. Fortunately, it's not B, it's not B. So when I switch it, when I bring the not B in front and I negate it, it becomes B. And when I bring the not C to the right, it becomes C. Oh, B implies C. Okay, so I use statement 3, and now we come to statement 2. C implies D. So the conclusion is not E implies B. Or for the record, anything logically equivalent to this is also a valid answer. Not because it says not in front, but you can always interchange those and negate them. So D comes first, but you negate it. And not E comes second, but when you negate not E, it becomes E. If you tell somebody, I am not going to the movies, and then you say, you know what, I changed my mind. I'm not going to do what I said. I'm not going to do what I said. I'm not going to go to the movies. That means you are going to the movies. If going to the movies is M, and you tell somebody, you know what, I changed my mind. I'm not going to the movies. And then your other plans fell through, so you call up your friend. You say, remember what I told you earlier? And your friend goes, oh yeah. You say, I'm not going to go to the movies. And you say, you know what? I'm not going to do that. I'm not going to do that. I'm not going to not go to the movies. Maybe you've given up on a course. You know, I'm just going to get an F in this course and that's it. I'm not going to pass this course. I'm not going to pass it. I've given up. I'm going to accept that I'm not going to pass it. Then you wake up the next day and go, you know what, that's ridiculous. Why would I do that? I'm not going to do that. I'm not going to not try to pass. That means you are going to try to pass. When you negate a negation, it goes back to the beginning. If you negate not M, you get back M. Okay, so you could have answered it either way. And let me just motivate this second answer. You may say, well, you already had an answer, not E implies D, the bottom left. Why are you changing it? Why did you go further than here? Well, I support that. You shouldn't. You shouldn't. But if you did the problem differently, you wouldn't have gotten not E implies D. You would have gotten not the right-hand side one. This one right here. You would have gotten not D implies E. And let's see how we get that. Let's see how we can get that. And the way I'm about to do it, it's no more awkward or less awkward than the beginning one. I mean, the original way I did it. Not D. Now, I look at number 3, and I see it starts off with not C. If I do contrapositive for number 2, I would get not D implies not C. Let me write that down. Not D implies not C. So I just used 2, and now I'm going to use 3. Not C, in turn, guarantees me not B. Now, I wanted something that starts off with not B. Well, if I do the contrapositive of number 1, I get that. That is not B implies not A. Okay, and then number 4 just tells me outright, not A implies E. Okay, not A implies E. So not D implies E. This one. Okay, so you can do it and get one of those 2 answers. I wouldn't get, say, the second one, but write it like the first one. Because if I mess up, I lose credit. I already have the problem 100% right. Why do contrapositive and maybe make a silly error? Or, even if you don't make an error, you're taking time away from working on the next problem. Try your best to use all the letters. Okay, that finishes the section on logic statements.